Semiconductors. In 1911, Dutch physicist Onnes discovered that the resistivity of mercury absolutely disappears at a temperature below about 4K. And if the temperature goes down about the 4K, the resistivity goes to zero. This phenomenon of superconductivity is of a vast potential importance in technology because it would be very useful to be able to cause change to flows through a superconducting conductor without thermal energy losses. This is what happened in our life, okay? Because we need electricity transferred to long time ago. And these electric line has resistance, so it causes energy, okay? If they don't have a resistance, we can save the energy. Superconductivity is much different from conductivity. In fact, the best of the normal conductors, such as silver and copper, cannot become superconducting at any temperature. And the new ceramic superconductors are actually insulators when they are not at low enough temperatures to be in a superconducting state.
This disk is made of a superconducting material that conducts current with no resistance at low temperatures. When the disk is cooled in liquid nitrogen, a small, powerful magnet will levitate above the disk.
One explanation for superconductivity is that the electron that makes up the current move in coordinate pairs. We call the pairs. One of the electrons in a pair may electrically distort the molecular structure of the superconducting material as it moves through, creating nearby a short-lived concentration of positive charge. The other electrons in the pair may then be attracted towards this positive charge. According to BCS theory, such coordinates between electrons would prevent them from colliding with the molecules and thus would eliminating electrical resistance. The theory worked well to explain the pre-1986 lower temperature superconductors. But new theories appear to be needed for the newer, higher temperature superconductors. 1972, Nobel Prize in Physics for developing theory of superconductivity, usually called the BCS theory. This is B. Barting, we saw it as my idol. This is a Cooper, this electron Cooper pair, and this is Schrieffer. Okay. In 1986, new ceramic materials were discovered that become superconducting at considerably higher and thus cheaper to produce temperatures. Practical application of superconducting devices at room temperature may eventually become feasible. Recently, 40 years ago, we have a new conducting material they called conducting polymers. Polymer used to be insulator, but they can become conducting. And they developed called third generation display devices called light emitting polymers. Okay. And those guys, they got Nobel Prize in Chemistry 2000s for the discovery and development of conducting polymers. Alan Higa and Magnamius, a Japanese Shirakawa. I'm happy to tell you, Dr. Alan Higa is my PhD advisor, also sponsors. I'm grateful to him.